I'm Charlie Dunnill. I'm one of the senior lecturers here at Esri. I will be running work package 4 and 6, which are interested in renewable energy to hydrogen and the scavenging of heat. So work package 4 is concerned with taking renewable energy and making hydrogen from it. Okay, so we put the energy into water, which we split into hydrogen and oxygen, and we can then use both the hydrogen and the oxygen. Now, Tata Steel has a huge need for hydrogen. It buys in a very large quantity of hydrogen, which currently is made from the reformation of natural gas, which of course gives out carbon dioxide. So not only can we offset their carbon by not producing hydrogen in this way, but we can also better use their available energy sources. So hydrogen is a really good energy carrier. We can use it to develop energy models, and we can use it to scavenge energy that would otherwise be wasted. So in terms of reducing industrial carbon, what we can actually do is we can scavenge wasted energy into something that is storable, usable and transportable and of higher value, which is the hydrogen. So that's really where it comes in. We can better use energy by using hydrogen. So we're using innovative technology to do this in a very cheap and efficient way. By using alkaline electrolysis set up in our state-of-the-art reactors, we can produce reactors that are very, very cheap. That means that we have a very, very low footprint of cost associated with the storage of this energy. We're then looking at the technology and how we can have microgrids and how we can move the hydrogen and store the hydrogen. But the main part of work package 4 is going to be setting up a shipping container that can be deployed as a solution that will take the renewable energy into hydrogen at an efficient way and low cost. I will be looking at using current gas standards in order to make my own little microgrids. So I will be using high density polythene pipelines that are currently used for the normal gas infrastructure. I won't be taking the gas infrastructure that's already there and trying to use that with hydrogen, though that is easily possible. We're also interested in the oxygen. So the oxygen is very, very important. It is a co-product, not a byproduct. So oxygen can be used for water cleaning and the processing that Welsh Water, for instance, use in order to clean their water. So one of the advantages, or another advantage of my technology, is that you can have multiple sources coming in. It's very simple technology, so if you get a burst of energy from a wind vane, you get a burst of hydrogen out. You don't blow up all of your electronics. So we can have wind and solar all coming in at the same time, which means we could end up having a water wheel producing some of the energy that goes in, as well as solar, as well as wind. So in terms of work package 6, we're now looking at thermal energy capture, which is one of my other interests. Industries such as Tata has a huge amount of otherwise wasted heat, but we're specifically looking at the moment at lower grade heat as well as the high grade heat. So if we can capture that heat and turn it into a storable, transportable, usable commodity, then we are effectively creating value from nothing. And if we can then use that value to offset their carbon, so for instance, if we take their heat, turn it into hydrogen, and then just use it instead of buying in natural gas, they can lower their carbon emissions. So the nice thing about the hydrogen is it's a universal energy vector, and it doesn't care where it's been made from. So we can have multiple sources of energy coming in. So I have a postdoctoral researcher working on thermoelectrics to try and come up with a scheme whereby we can take their waste heat from various areas of the plant and put it into hydrogen using the technology in work package 4.